Please welcome to the stage Josh Santos.
Hey folks, afternoon. Hope everybody's feeling lively after lunch right now. My name is Josh Santos and I'm the co-founder and CEO of a company called Noya. We're based in West Oakland, California, and I'm super excited to be in front of all of you all today. At Noya, what we're building is an approach to DAC that consumes power flexibly, ultimately sidestepping DAC's big power problem. As you all know, clean power is hard to come by these days, and by consuming power flexibly, we can sidestep that issue. We also produce a lot of water with our process as well. You may have seen at the bottom row of Grant's table, there were 2 companies that have explicit water sales as part of what they do. We are one of them. We produce 6 tons of water per ton of CO2 that we capture, and we do all of that while producing highly permanent carbon removal credits. Our approach to DAC is modular. You may have seen the module that we were building right here. That's the very first one that we've ever built. This is here at our headquarters at West Oakland as we're assembling and doing the initial validation on it. And everything that we do surrounds this module. It starts with moving air, like you might have heard about with DAC, through a piece of equipment. For us, the piece of equipment is the module, and inside of that module sits a material that we developed in-house. We've got PhDs that have done the material development from nothing to where we are at now. And that material is reactive with CO2 and water in the ambient atmosphere. Once we had saturated our sorbent with CO2 and water, we turn on electricity and flow that electricity directly through our material itself. Unlike other approaches to DAC, our approach only requires power. We don't need heat. And we can do that because our material is electrically conductive. And so we flowed electrical current straight through our material itself for what we like to call an electrothermal approach to DAC. In step 3, we move the CO2 and water that we produce out of our system so that we can use the material to capture more water. And in step 4, we separate the two from each other using temperature to be able to have a pure stream of CO2 for injection underground and a pure stream of water for sale to folks that might need it. We're all on our way to developing our first commercial project right now. You can see it's going to be around 1,000 tons per year, built in 2027 with injection from the very beginning. We're currently validating 2 different project locations for this facility, one in Texas and one in California. And given the modular nature of our technology, we will plan on scaling up at the same location. So as we scale up over time, going to 100,000 after that, and then ultimately 1 million tons, we are aiming to be able to achieve a massive scale very quickly using the approach that will come off of assembly lines, just like some of the Model 3s I used to build during my time at Tesla. We've got a lot of the partnerships that are important for us to be able to get there already. We've sold millions in carbon removal credits. We've got an MOU for water offtake with California's largest, one of California's largest agricultural companies that is worth about another $3 or $4 million per year just in water sales. We've got MOU signed with land partners and land transportation and storage operators in Texas, California, and Louisiana. And we are working with a company called Ikegami, one of the largest EPCs globally, to act as our very first EPC. Additionally, we are manufacturing our material with a company called Johnson Matthey. Johnson Matthey is a 200-plus-year-old materials manufacturer based in the UK that has facilities all over the world. And they are doing extrusions for our carbon capture sorbent actively today. We've been receiving shipments from them since the beginning of the year to go into the demonstration facility that we are building in the Bay Area right now. So we are excited to be building a demonstration unit in the Bay Area. It's actually in a town called San Leandro. If any of you are ever in the Bay, I'd love to host you around the facility. It's about a 20-minute drive from Oakland and about a 30-minute drive from SFO. But we're building the future of DAC right in the Bay. So excited to see you all at our site tour over at San Francisco Climate Week, and excited to see some of you all outside of that as well. Thanks so much for the time, and hope to stay in touch with all of you very soon. Thanks.
Please welcome to the stage Jessica Gross.
Hi, everyone. I'm Jessica Gross. I'm a program manager for the Carbon to Value initiative. And this is a time I want to tell you a bit more about the program and relevance for those in the audience, both from the startups and corporates. So C2V was founded in 2020. It's a program run in partnership between Urban Future Lab at NY School's Tandon School of Engineering, Greentown Labs, and Fraunhofer USA. It has had 4 cohorts so far, with our 4th year wrapping up this April. And the mission is to build a carbon tech ecosystem and foster partnerships between startups and corporations. We've had a lot of success in the 4 years so far. So we've had 35 startups come through the program to date. They've raised over $550 million, and we've had 11 partnership announcements so far. In terms of the program itself, to give a bit more about it, it is a program that usually has between 8 to 10 startups. The startups go through a 6-month accelerator program, which is specifically designed to help startups bridge the gap between technology development challenges of today and the carbon tech marketplace and policy landscape of tomorrow. All the startups have the opportunity to work with C2V organizations and corporate partners that we have, and the startups are also matched with advisors throughout the 6 months where they build out development plans and have support throughout the time in the program. Outside, we also set up networking events and ecosystem building opportunities as well. In terms of the technology focus areas, so we focus on TRL 4 to 7 and are open to a broad range of carbon technologies. I realize this neon green is very hard to read on the screen, but on the slides there, it is saying the technologies that we focus on tend to be between carbon capture, carbon conversion to value-added products, CDR, and enabling technologies. So while these might vary slightly year to year, these are typically what we look for in our applicants. We've had, again, many startups to date. There are 35 startups across a wide spectrum of these technologies. And after 4 years, we've had many success stories as well. So just to highlight a few of them here, in 2021, C2V resulted in a partnership between Fluor and Carbon Free to commercialize their second-generation mineralization technology. In 2022, Carbon Direct led Airco's $30 million Series A, where they got to better know one another through the program and better understand their technology. And in 2023, C2V strengthened a collaboration between CRH and Carbon Upcycling, which resulted in their $27 million Series A, as well as a project installation. And last but not least, one of the biggest successes, or part of the biggest success of the program, is our Carbon Tech Leadership Council. This is an invitation-only group of corporates, nonprofits, and government leaders who foster commercialization opportunities. They identify avenues for technology validation, testing, and demonstration. So startups have the opportunity to work firsthand with these leaders, and these leaders have the opportunity to support the startups throughout the program. And just to highlight, this isn't just for mid-level managers. We have buy-in from top-level executives at all these corporations who really help support and propel the program throughout their companies. That being said, if you're interested in learning more, I'm happy to speak further, both for corporates and startups. So for corporations, if you're interested in participating and being part of the Carbon Tech Leadership Council, happy to provide more information. And for startups looking to apply, our next cohort will open up in Q2 of 2025, so keep a lookout for that. So thank you all, and next up we have David from Zero Carbon Systems. Oh, I could provide it for you afterwards. Okay. I think these slides have been hard to read, so I will provide them after.
Hi, I'm David Elenowitz. I'm CEO of Zero Carbon Systems. Just to first start off with a little background on myself, my original career was in private equity for over 25 years. I invested in and ran a number of companies. The last company I bought was a flooring company called Empire. I went in as CEO. I grew it from 40 million to 700 million in sales. Then I sold it, and then sometime after that, a bit after that, in 2018, I decided to shift out of private equity and into trying to help solve climate change. I set up a new entity called Zero Carbon Partners. I put $100 million of my capital, personal capital into that over time, and set about looking to invest in scale companies low carbon space. One of the first companies I invested in was Global Thermostat, one of the original 3 DAC companies, widely considered to have the best or among the best technologies in the world for DAC. I also became a senior advisor there, and during my time there, while Global Thermostat had excellent core technology, I felt that their design could perhaps be improved, so I came up with my own design, hired a team of 25 engineers, set up Zero Carbon Systems, and then a little under a year ago acquired Global Thermostat. So with that intro, I'll turn to the slides. So first, as noted, we've been in stealth mode for about 4 years, came out of stealth mode when we acquired Global Thermostat. We have a first-generation 1,000-ton DAC plant that we built, and then we're moving towards a 2,500-ton DAC plant coming subsequently. Oh, that's not how that works. So, Okay, we have a significant tech center in Denver with a number of test rigs and pilot plants. We have a single core tester, multi-core tester. That means the cores of our monoliths, which are our core technology, which have very high surface area to volume. We've got a big team, over 25 people in Denver doing our tests. We have a single panel pilot that is a pilot for our unit, and then notably our next gen pilot for our next gen design. I'm happy to announce it is coming online as we speak, so we're very excited about that. In terms of our design philosophy, it's been to start very large and then go backwards from there. So unlike many DAC startups that start small, it's got a lot of advantages, of course, that you can number it up, but it always has a little bit of a potential scaling risk. We felt instead, let's take additional time, let's build a megaton scale plant first. Design a megaton scale plant first, which is what we did, and then we worked backwards from there. As a consequence, we came up with certain design decisions. One is to have a continuous process, which makes us highly scalable and also low cost. So we have a large scale core units, over 100,000 tons. Our focus, again, is maximizing throughput to lower our CapEx per ton, and then we also have substantial heat recovery, which allows us to have lower OpEx per ton. And then notably, we have a componentized design. One of the advantages in modular DAC is that you don't have to spend a huge amount of time and capital doing a stick-built plant. Well, we've come up with a componentized design that gives us the best of both worlds. So we're able to build virtually all the components off-site, ship them to site, and then assemble them on-site. But that gives us the modular DAC benefit. But at the same time, it also gives us the benefit of large scale. So we have a lot less steel, a lot less piping, and we're also able to leverage larger scale industrial equipment. We feel our tech and our design have been substantially de-risked. We spent over 10 years over time between ourselves and Global Thermostat, who we acquired, and then over $100 million of development expenditure. And then okay, sorry. Last thing, and then we feel that we check many of the important boxes for DAC technology. So first, excellent core technology, widely acknowledged we're among the best in the world. Superior engineering design, which is highly scalable, continuous, clear pathway to low cost because of our high throughput allows us to leverage a low CapEx per ton. A clear pathway to low energy, substantial heat recovery, giving low energy per ton. Relatively strong management team, we think, and strong capital raising ability because of all the above, and also my own personal commitment, a lot of skin in the game. So with that, I think we're at time, and I will introduce David Berliner. Come on in.
Hi, thanks to the organizers for putting on this session. My name is David Berliner. I lead the strategic finance function at Origen. Next slide, please. Oops. Perfect, thanks. At Origen, we use limestone rock to remove carbon from the air. We do that, or there's two things you need to do to be able to use limestone rock to remove carbon. One is you need to have a kiln that gives limestone rock its superpower, turn it into lime. And we do that using a proprietary oxy-fuel flash calciner kiln design. What that means is what we get out of our kiln is two product streams. One is the mineral lime, and two is a pure stream of CO2 that includes both CO2 from that limestone rock and CO2 from combustion into one pure stream that's then available for sequestration. We've created the mineral lime without any carbon emissions, and then we put that lime into passive air contactors and let it do what it wants to do, which is sponge up CO2 from the atmosphere. Three things about Origen's process that we think are unique and different. One is we use limestone as our sorbent. It's cheap, abundant mineral. Second is all of the technology that we use is proven at industrial scale. Supply chains exist at industrial scale. When you think about a megaton facility, it looks a lot like what you'd see at a cement plant or a lime plant today. So there's not a big stretch of the imagination to understand what we look like at scale. And third is most of our energy comes from molecules instead of electrons. And where there's a increasing competition for firm green power, we think that that gives us an interesting deployment advantage as we go out to build at scale. Again, we use molecules, but all the CO2 from our combustion process is captured as part of our overall system. Earlier this year, we announced the closing of a Series A, $13 million, with some really great partners. And I think this is one of the things that's going to help companies like ours get over these next big hurdles and build first commercial plants. You see some of them here, and can't say enough in particular about, I think, Hatch is here today, global EPC partner, as well as Shell, great partners. We're using some of that Series A to build our first commercial facility in North Dakota. Our first demonstration scale facility up to 1,000 ton per annum, working with another great partner, EERC, hidden gem in the US. They used to be part of the Department of Energy National Lab System, but decades of experience at the forefront of carbon, energy, hydrogen, et cetera. If you don't know them, you should get to know them if you're looking for a commercialization test center. And in parallel, we're progressing on our first commercial facility, which we announced earlier this year. We're co-developing with Shell and Mitsubishi as part of the Pelican project. So over the next day and a half, I'm here. I'd love to tell you more about our technology and some of our thoughts on energy. I'm excited for the panel at the end of tomorrow to hear more about that. I'd love to tell you why we love our partners and make introductions to any of them if you're looking for an EPC partner, carbon DAC hubs, et cetera. I'd love to tell you more about that commercial project and talk to you about our offtake philosophy and investment opportunities we have following on that Series A, as well as more we'll be doing end of this year and into next. So thank you very much. And next up, Chris Jones.
Hey everybody, how are you doing? My name's Chris Jones. I know many of you have been working in the DAC field for a number of years, 18 years in the field, starting in 2008, 2009. But my startup is new. I've been working in amine sorbents for the duration of that period in my job at Georgia Tech in Atlanta. And then in 2023, I saw the opportunity to start my own company, leveraging the learning that I gained working in DAC for the last 15 to 20 years. With my partner, Mark Davis, it's his sixth startup. His most successful startup is now on NASDAQ, trading under the ticker RNA. And together, we're combining his entrepreneurial experience as well as my DAC experience to create ZeoDAC. So we were seed funded in 2023, 2024, and we're preparing for a raise late in 2025 for our next round of development. We're based in Atlanta, Georgia, and our business model is the model of a technology provider, right? So we're not going to be developing our own sites ourselves, but rather hopefully partnering with many of you in the room to deploy our technology at some of your sites. Our current development goal is to have our first demo unit operating early in 2026. We're doing the design of it right now, and we have 2 smaller scale units operating in the laboratories in Atlanta, Georgia. Next slide, please. So we differentiate from the work that I've done in the past on amine sorbents in that we are a zeolite-based DAC company. And so one of the advantages of the zeolite-based technology is essentially every component of the supply chain exists, and it exists on a large commercial scale already. So a lot of my past experience working on DAC development has been trying to work towards building the supply chains that are necessary to provide the sorbents that everybody wants to use. In contrast, if you wanted to buy ton-scale zeolite that we use today, you could do that on any continent on Earth. So we're a solid sorbent-based technology, but because we're working with zeolites, we are focusing on particular climates, right? So we're not going to deploy in New Orleans, Louisiana. We're not going to deploy in Houston, Texas, because we have to remove the water first. So our approach is a 2-stage DAC technology, removing water and producing water as a co-product, and then removing the CO2. Working in a very humid climate, that would give us massive water removal costs. But in a cool or a warm and dry climate, we have very advantaged economics along with very stable materials that are going to last on the order of 5 to 10 years. So that's what ZeoDAC is all about. If you have any interests, I'd be happy to chat with you in the rest of the afternoon. Unfortunately, I will not be here tomorrow, but I'm easy to find on the web if you have any questions, and I'd be happy to talk with you. So next up is another zeolite company. So there's now 5 zeolite DAC companies that I'm aware of, and we're going to hear from Ikegami.
So, good afternoon. I'm Ikegami from Price Savers. I'd like to introduce our company, Price Savers, Japan's first DAC startup using the innovative zeolite technology. So, wait. Actually, the slide is lost somehow. But, okay, so we are developing the zeolite-based DAC technology, and we use the innovative zeolite solvent and also the machine optimized for zeolite. I'm not sure how familiar you are with zeolite, but zeolite is a porous material. So this is zeolite itself, and this is a porous, the molecule frame of zeolite, and it captures CO2 physically here. So we don't have the chemical reaction. We just use the physical reaction. What makes it unique is we can, take the CO2 out from here without heat. Instead, we just use a vacuum. So we don't require heat at all. And we can also increase the potential of zeolite by world's top 3 zeolite synthesizing technology. So for example, we can inject metals or exchange ions and increase the performance, like capability to capture CO2, and increase their speed to capture and makes the easiness to dissolve. And actually, this synthesizing technology is very difficult. I mean, there are only limited numbers of laboratories which can do this kind of synthesizing, and we have like world's top 3 technology for that. And also, because zeolite has a different characteristics from other solvents like amine, we are dropping the machine by ourselves, and it works without any heat, just electricity plugging, and we use vacuum for the desorption. And so far, we have already developed the, okay, somehow the material is not working well, but we have already developed the 10 kilogram per day scale bench scale machine, and we are trying to develop the prototype this year. And next year, we want to demonstrate 100 tons per year scale with our commercial machine. And we have 4 major merits with our direct heat capture system. First, we don't require heat. And second, we don't require water. And actually, we can generate water. And third, it's very cheap with the capex because of the zeolite. It's very cheap and it's very durable, like 10 years. And also, we don't require construction cost that much because we go with the modular approach. And we're a strong team. I'm a Syrian trainer with energy background. My co-founder Kenter is a top scientist in the zeolite field, and our VPOE Yusuke, he experienced IPO as a scale tech startup. And we have 2 advisors from Climeworks. One is the ex-CTO from Climeworks, Carlos, and also ex-chief commercial officer at Climeworks, Daniel. So we are advancing our technology, getting the advice from them. And sorry, it's not working. Yeah. Can you go next? Oh. So okay. So we start from Japanese market, especially for the carbon utilization use case, like agriculture, tomatoes, strawberries. We are gonna do some projects in Hokkaido next year, hopefully. And then with tractions, we'd like to go to the global market, like US or Canada, Australia, Europe, these countries, for the kiloton size scale in 2027, 2028, and then be ready for the megaton size by 2030. And we have raised around 5.6, including $4 million US grants from Japanese government. So we expect doing our series round next year. So that's it. we are really looking forward to collaborate with international business partners and also welcoming the investors for our Series A round. So please talk to us. Thank you very much. Very nice to meet you.